Okay, welcome back. More examples on 3D vectors. So we have 3 points, A, B, C, and these points are in the 3D space. And we just want to know if these 3 points are collinear or not collinear. Collinear points are points that are on the same line. A line passes through all 3 of them. And the non-collinear points are points that are not all on the same straight line. So if we have a point A here, and we have point B, and we have a point C here, if you can pass a line through all 3 of them, then you say that the 3 points are collinear. And otherwise you say they're not, because point C could be somewhere here, for example. In that case, it would not be on the same straight line. So it's needless to say that when the 3 points are collinear, then the vectors AB and BC are parallel, right? You can say vector AB is parallel to vector AC, right? And also you can say that vector AC is a multiple of vector AB. So maybe vector AC is 3 times the size of vector AB. Maybe that's the case. Maybe it's 2 times. Maybe point C is on the left side of point A, then in that case K will be negative, all right? But end of the day, one vector has to be a multiple of another vector for you to say that the 2 vectors are collinear vectors, okay? Or the 3 points are collinear. So we have 3 points, and we want to see if these 3 points are collinear points or not. Okay, so I think we're going to do the same thing. We're going to say, let's find vector AB. So that's x of b minus x of a, y of b minus y of a. And if you do this, it's going to be x of b minus x of a. So that's 5 minus 6, 0 minus 2, 10 minus 0. So that would be negative 1, negative 2, and 10. And similarly, if you find vector AC, x of c minus x of a, I'm writing the formula. And it would be z of c minus z of a. So x of c minus x of a. So that's 5 minus 6, 2 minus 2, and negative 2 minus 0, which would be negative 1, 0, negative 2. Okay, so now we just have to check to see if these 2 vectors are matching or not. Okay, not matching, like if these are multiples of one another or not. So we are checking to see if negative 1, negative 2, comma 10 is k times negative 1, 0, negative 2. The question is, can we find the scalar k? Can we find a real constant such that this vector equals k times that other vector or not? So we see that if k is 1, then 1 times negative 1, it works out. So this is negative k, 0, negative 2k, okay? So negative k equals negative 1, and the 0 equals negative 2, and 10 equals negative 2k. These are the equations we end up with. From the first equation, k equals 1. Second equation, obviously it's a wrong statement because 0 is not equal to negative 2. Okay, so that is incorrect. And from the other equation, k happens to be negative 5. Negative 5 plus negative 2 is positive 10. So you see that we don't have a unique value for k such that AC or AB be equal to k times vector AC. Or it's the other way. Which one I did right here? So AC, it doesn't matter. It doesn't matter. One has to be multiple of the other. You can say AC is 3 times vector AB, or you can say vector AB is 1/3 times vector AC. It doesn't matter. The idea is the same. So whether you say k times the vector on the left equals the vector on the right, or you say k times this vector on the right equals the vector on the left. It doesn't matter. So what matters is that we could not come up with a specific k value, whether fraction or integer. We couldn't come up with a unique value of k such that left side be equal to right side. And that means that these 3 points are unfortunately not on the same line. So we say that 3 points A, B, C are not collinear. They're not on the same line, obviously. Okay? So that was one example we did. In this next example, we want to see if these 2 vectors are collinear or not. So when do we say 2 vectors are collinear? Whenever they're parallel to one another, or whenever one is a multiple of the other. But the thing is that when 2 vectors are collinear, like these 2 vectors are collinear right now, the angle that they make with one another is 0, isn't it? Okay? So I'm going to use the dot product formula. I'm going to say cos theta equals u dot v divided by this magnitude. I'm going to evaluate this fraction on the right. And if I ended up with cosine of 90-degree angle, which is 0, then I'm going to say, no, I forgot for a second what do you want to prove. We just want to show that these are collinear or not. Okay, sorry. So if I end up with an angle of 0 degrees, so I should end up with cosine of like maybe 180 degrees or cosine of 0. Yeah. If I end up with an angle that is 0, which means that 2 angles, the 2 vectors are making a 0-degree angle with one another, or if I end up with 180 degrees, which means that one angle is to the left, one vector is to the left, one vector is to the right, and the angle in between is 180 degrees. Still, I can say that they're collinear. If I end up with something like that, I can conclude they're collinear. Otherwise, if I get a cosine value of an angle where the angle is like, I don't know, 120 degrees or 25 degrees or something like that, I would say obviously the 2 vectors are intersecting one another. They're making an angle with respect to one another, and they're not collinear. But if I end up with a situation where I get cos theta be equal to, let's say 1, then it means that theta must have been 0, because cosine of 0 is equal to 1. And when the angle theta is 0, it means that 2 vectors are making an angle of 0 with respect to one another. That means that the 2 vectors are collinear. So we don't know. We're going to find out. So here, 624.936. And here we have 6 squared, 2 squared, 4 squared, and 9 squared, and the rest. For the dot product, I show the work. 6 times 9, 2 times 3, and 4 times 6. In the bottom, we have to use a calculator. And 6 squared, 2 squared, 4 squared, 9 squared, 3 squared, the answer will be 7,056. Okay, so this means that cos of theta is the numerator. 6 times 9 is 54, 2 times 3 is 6, 4 times 6 is 24. Add them up, it's going to be 84. Okay, so theta would be inverse cosine of this fraction. Okay, inverse cosine of this fraction, whatever it may be. Now, using the calculator, we are going to find out what this is. So, what is 84? Let me see, 84. Yes, 84 squared is actually 7,056, believe it or not. So this means that we have 84 over 84. And that's inverse cosine of 1, which means that it is 0. So theta equals 0 is the final result we got, which means that the two vectors are making an angle of 0 with respect to one another, and automatically it means that the two vectors are actually collinear vectors. So I would say vector u and vector v are collinear, which means that the vectors are parallel to one another. And you can actually see that now. If you multiply 6 by 1.5, you get 9. If you multiply 2 by 1.5, you get 3. And if you multiply 4 by 1.5, you get 6. So basically, vector v is 1.5 times vector u. So you see that one vector is actually a multiple of the other. So after we did all this work, we noticed that one vector was actually a multiple of the other. If you multiply 1.5 as a scalar by the first vector, you get the second vector. And that means that the vectors are collinear, of course. Write a unit vector orthogonal to this vector u. Orthogonal means perpendicular, okay? So right now, this vector and this vector, they are orthogonal. Also, these vectors are orthogonal. Also, these, okay? These are all orthogonal vectors. So, and not only this vector, this one is perpendicular to this, but also this one is perpendicular. This one is perpendicular. And this one is perpendicular. And that one is perpendicular. And this one is perpendicular. So there's like so many vectors you can find that are orthogonal or perpendicular to a given vector. And we want to find one of those millions of vectors that are orthogonal with vector u, but we want that vector to be a unit vector actually. So how do we do this? Well, that vector, I'm going to call it vector A, and I'm going to use the important property we talked about. I said the dot product of two perpendicular vectors is always 0. So this means that the vector x, y, z, which I don't know its components, I wish I knew, dot 6, 8, 10 is supposed to be 0. It has to be, otherwise the two vectors will not be orthogonal. So this means that 6x plus 8y plus 10z equals 0. I notice everything is even, all the coefficients are even numbers. I divide both sides by 2. So I get 3x plus 4y plus 5z equals 0. Okay, now the question is, what are the x, y, z values that would satisfy this equation? Obviously, we have one equation and 3 unknowns. Nobody can solve that. Therefore, we are going to find one of the millions of solutions that this equation may possibly have. There is no unique values for x, y, z. I tell you that, okay, x must be this much, y has to be this much, and z has to be that much etched in stone. And there's no other value. There's no such thing. This equation, because it has more unknowns, has like more than one unknown, has infinitely many solutions. So among those infinitely many solutions, we have to find one of them. So I'm going to select like values. Let's say I go x is 2. I select x to be 2, y to be 1, okay? Or any number you feel like it. And then I'm going to plug in there. So these are values I selected. So I get 3 times 2, 4 times 1, plus 5z equals 0. So that is 5 and 4. 5 plus 4 is how much? So x is 2, so that's 6. 6 plus 4, sorry. 3 times 2 is 6. 4 times 1 is 4. 6 plus 4 is 10. So that means that 5z equals negative 10, and z becomes negative 2. Okay, so we are saying that if you have a vector with these components of 2, 1, and now we found negative 2, if this is your vector u, then you can say that this vector is orthogonal. Oh, sorry, not u. I have to change the name because u was the original one. A, I called it A. So this is the so-called vector A, which is orthogonal with vector u. And if you find the dot product of this vector with the vector u, you will see that it will definitely be equal to 0, which means that vector a and u are perpendicular or orthogonal to one another. But the question says find the unit vector. Now, the magnitude of this vector, obviously, 2 squared, 1 squared, negative 2 squared, is going to be 4, 4, and 1. That's we squared, and 9 is 3. So the magnitude of this vector right now is 3 if you use the formula. So this would be magnitude of A is like 2 squared, 1 squared, negative 2 squared, okay? So that is 3, and this is not a unit vector, obviously. We want to find a unit vector that is orthogonal by that vector u. So what we should do, we have to grab this vector and divide it by its magnitude, which is 3. So the answer would be a hat. It would be 2/3, 1/3, and negative 2/3. So this is the unit vector a hat we were looking for. So not only it is a unit vector, okay, because I divided vector a by its magnitude clearly, but also it is perpendicular or orthogonal to the given vector u. Okay, so I hope these examples gave you a better idea of different types of questions that are dealt in three-dimensional vectors. Thank you.